Hello everyone, welcome back. So today we're going to be doing lesson number 2 of the Crypto Zombies course, which is a Solidity course from beginner to immediate with smart contracts. If you haven't watched the first lesson, please do so before watching this. And yeah, hopefully it was useful. And even if you hadn't done too much coding before, you're able to follow along a bit. So today we're going to be doing lesson number 2. So the first chapter is just an overview. So in lesson 1, we created a function that takes a name and we used it to generate a random zombie. In lesson 2, we're going to make our app more game-like. We're going to add some more functions and do some more fun things to generate zombies. So this is something that they developed here, and I think we're going to be working towards this lesson. Here's how the zombie could eat a person, and it mutates the zombie here. So you can add these interesting interactions potentially between characters or assets, NFTs. This is mappings and addresses. So in the last lesson we introduced a few data types. So we had unsigned integer and string. So these are 2 new data types. We've got mapping and we've got address. So the Ethereum blockchain is made up of accounts. So we've all got these like wallets. So we've all got these. So each account has a balance in Ether, and each account has an address. So you can think about these as like a unique identifier that points to that account. So this is, say, a public address to send Ethereum to, which I believe to be the Crypto Zombies team. So now these are the addresses that our ENS names resolve to. If you try and send money to ENSTP, ENS trading post.eth, it'll resolve to the this public address like so, or each one is individual to the ENS name it resolves to. So let's take a look at mappings. So here is how they defined a mapping. So we can see that this is a mapping here of address to an unsigned integer, and here is a mapping from a uint unsigned integer to a string, and here this one's called account balance, and this one's called user ID to name. So let's put it to the test. So we're going to declare here a mapping called zombie to owner. So the key will be a uint. So from a uint to an address, which is a value. This is going to be public. If I can type so that anyone can access it. And the name is zombie to owner. Okay, perfect. Oh, sorry, no, don't need parentheses here. Semicolon to finish, and it's saying create a mapping called where the key is an address, so from an address to a uint, no public or private identifier, and this one's called zombie owner, zombie count, semicolon. Check answer, perfect. So this is on message.sender. Okay, now so you might be thinking, what is message.sender? So essentially, when a transaction or a function call is made, there's this message object, and this is available to anyone. And this has got certain properties attached to it, such as the gas and who sent the message. So this is a global variable, which is accessible to anyone, called message.sender. So we can use this to see who initiated the transaction or function call. Okay, so we can use this for different things, but yeah, that is what a message.sender is. So in here, we're going to put it to the test with an example here. So this was an example. We've got this mapping favorite number. I'm going to use the sender's address. We're going to map that to the uint, which is the favorite number from when it's been set in this function. Okay, so we're going to put it to the test. So what it's asking us to do is, after we get back the new zombie's ID, let's update our zombie to owner mapping to store message.sender under that ID. So our zombie to owner mapping, like it did with the favorite number there, and we're going to use message. Oh no, we're going to use the ID and that is going to be equal to message.sender. Okay, so we're using this global variable, the address, which is available to everyone, of message.sender, and we're going to set that equal to the ID of the current zombie is going to map using this mapping here to the address of the sender. Okay, so we could use this to every time the zombie was created, we know who the zombie belongs to, because they'd all be in this mapping. Okay, check the answer. Ooh, made a mistake. Let's have a look. Show me the answer. Oh, so we missed the second part. Second, let's increase the owner zombie count for this message sender. Okay. So it's giving you a bit of an example here of how we can increase a number. So here, if we had just a value that was equal of called number, say, that was equal to 0, we could increase the value of number by 1 by using this code here. So we can do the same for zombie to, I'm sorry, for owner zombie count, we're going to increase that plus plus by 1. Oh, sorry, again. The owner. Right, so why do we need a message.sender there? Well, we need to use this mapping again. So in the owner zombie count, we give an address and it gives us a uint. So we can for the address of this person, we can increase the global, the owner zombie count by 1. Okay, next lesson. Chapter 4 is require. So in lesson 1, we made it so users can create new zombies by calling create random zombie. However, we don't want anyone to be able to create a new zombie, so we can use this require. It's a function which allows us to set certain requirements in order to be able to run certain functions. So let's put this to the test. So we're going to start down here. So put require statement at the beginning of create random zombie. So how it's done it above. So we've got require. The function should check to make sure owner zombie count for this address, or the address of the sender, is equal to 0. Check the answer. Perfect. Something that I should have said in the previous lesson as well is if in coding, if we use 1 equal sign, so say uint A equals 0, uint B equals 0. Using 1 equal sign like this, we're assigning a value. So we're saying that A is equal to 0, B is equal to 0. But if we were to use 2 equal signs, so say we were to say if A is equal to, so B, then do something here. So this is when we'd use 2 equal signs if we're evaluating these against each other. So this is saying is A equal to B, and this is saying assign A the value of 0. Okay, so let's do this next one. So inheritance. Okay, so what we can do is contracts can inherit certain behavior from other contracts. Okay, so this is a feature of Solidity which makes it more manageable for contracts. So it's called inheritance. So as you can see here, this is an example where we've got a contract called Doge, and this does something. And then we've got a contract, we'll create a new contract, we're going to call this baby Doge. And if when we create the contract, we say contract baby Doge is Doge, it inherits certain properties from the Doge contract. Okay, we still need to figure out exactly what those properties are, but I'm sure that will become more clear along the way. So we're going to make a contract called zombie feeding. So starting here, so contract zombie feeding, and this contract should inherit from zombie factory. So is zombie factory. Okay, and then this is where we're going to put something inside our contract. Let's check our answer. Perfect. Chapter 6 is import. So if we want to import some of our code into different Solidity scripts, so here we've got a zombie feeding.solidity script, like a file, and here we've got our other zombie factory.solidity scripts from the previous lessons. So if we were to, if we wanted to use some of the functions and different objects and items that we've got in here in this script, we don't want to copy all across, we can use this import statement to bring in the things from here. Okay, so to do this, we're going to do import, and we're going to import zombie factory dot solidity into our new file, which is here. And now something to be aware of, you just need to say that it's in our current folder. We just got to use this dot /, that's all it's saying. In our current folder, find this file and import it into zombie feeding. Okay. Oh, I think we've got a semicolon. Let's try again. Perfect. Okay, storage versus memory data location. So in Solidity, there are two locations you can store variables, storage and memory. So let's see what the difference is. So storage refers to variables permanently stored in the blockchain. Okay, which is kind of cool. You could have a variable called ENS trading post is cool. Not, and you could store that in the blockchain permanently. That's kind of interesting. So memory variables are temporary, so they're erased after between external function calls to your contract. Okay. So what's this saying? It's just some example here. So where have we got storage and memory being used here? I'm not sure. So let's put it to the test. So we're going to create a function called feed and multiply. It's going to take two parameters. The first one's going to be a uint called zombie ID, and the second one's going to be a uint called target DNA. The function should be public, and I think that's it. We don't want to let someone else feed our zombies, so we're going to add a require statement in. So we're going to require to verify that the message dot sender is equal to, so remember the two equal signs because we're asking is it equal to that, is equal to this zombie's owner. Okay, so this zombie's owner. Okay, so similar to how we did in create zombie, so this is a function now that we've imported from here. So let's have a look in our create zombie. So previously we did this, so zombie to owner with the ID. So this is a mapping, so if we give it the ID, we can get the address. So we can require that the message.sender is equal to, we've got an ID here, this zombie ID. And what was our zombie to owner? So I believe it's to be zombie to owner using our zombie ID with a semicolon at the end. So that's the second part. We're going to need to get this zombie's DNA. So the next thing our function should do is declare a local zombie and create my zombie with a storage pointer. This sounds a bit tricky. Set this variable to be equal to the zombie index in our zombies array. Okay, how do we do this? So we're going to create a zombie called my zombie, and this is going to be equal to right, so it's going to be from our zombies array, which you remember from the last lesson is a big long list of our zombie objects. So we're going to say my zombie is equal to the ID number of this zombie. So this is going to be the ID number, so it might be zombie um, 27 say, and this is going to get the 27th element within our zombies array. Okay, and we're setting that equal to my zombie. So I believe that's to be correct. Let's give it a check. Oh, right, we've made some errors. Let's see. Show me the answer. Okay. Oh, we forgot this storage part here. Okay. So this is with our storage and memory data locations. So what we're going to do, so it's because we want to permanently store this zombie on the blockchain. Okay. Understand that? So storage my zombie. I think that's correct. Perfect. Next lesson is zombie DNA. So let's finish writing the feed and multiply function. So let's put it to the test. What is it asking us to do? So first we're going to make sure that target DNA isn't longer than 16 digits. Okay, so it's telling us how to do this. So it's saying to do this, we're going to set target DNA equal to what target DNA was before, modular sign with the DNA modulus. If you don't understand what this does, don't worry too much. But that's just used to make sure our DNA isn't longer than 16 digits. So our next function, we're going to declare a uint. Next, sorry, our function should declare a uint called new DNA and set it equal to the average of my zombie's DNA and target DNA per example above. So to get an average, what we do is we add the two things together and divide it by 2, because that gives us the middle value between these two. Okay, so if it was 10 and 20, okay, we add those together, 30 divided by 2 gives us the average, the middle between 10 and 20 is 15. Okay, so to do this now, we are going to do so my zombie. Okay, so it's my zombie's DNA. So because my zombie is now an object, it's from our zombie structure here. Okay, so because we created a zombie object, the structure's got these attached properties. So one's name and one's DNA. Okay, so what we can do is we can access the DNA of this my zombie object using this .dna. So we might just need a bracket here. I'm going to add that to the target DNA, and we're going to divide by 2, and that's going to give the average of my zombie's DNA and the target DNA. And then once we have our new DNA, let's call. So to call a function, if you remember, we type the name of the function and we give it what it needs to run. So I can't remember what it needs to run, so let's have a look. So when I create zombie, we need to give it a name and a DNA. So we need to give it a name, which is going to be, what's our name? Oh, so let's set our zombie's name to be no name. So the name at the moment is going to be no name. And the DNA is going to be what? Oh, once we have a new DNA, so we're going to be using this new DNA value. Okay. So doing this, we can create a new zombie called no name with this new DNA after running this feed and multiply function. Perfect, next lesson. So more on function visibility. So do you remember how last time we talked about public and private? So there's 2 more examples of visibility for functions. We've got internal and external. Internal is the same as private, except it's also accessible to contracts that inherit from this contract. So it sounds like what we want. So we've been inheriting from, remember when we created this contract, we did zombie feed and is zombie factory, so it's inherited. And external, similar to public, except that these functions can only be called outside of the contract. Okay, so I'm not fully sure what internal and external are, but they are more function sort of modifiers similar to public and private. So let's go with that for now. So let's put it to the test, where we're going to be writing this. So it's going to say edit the function defined below. Okay, so we're just going to change it from private to internal. Is that spelled internal? Spelled correctly? Okay, perfect. What do zombies eat? It's time to feed our zombies. What do zombies like to eat most? Crypto keys. Okay, so we've done inheriting from other contracts. But for our contract to talk to another contract on the blockchain that we don't own, we need to define an interface. Okay, so I assume this is an interface between the two different contracts. This will be a simple contract where anyone could store their lucky number. Example here. Let's say that we had an external contract that wanted to read the data in this contract using get number. Okay. First, we'd have to define an interface to the lucky number contract. Okay. So this is how they create an interface here. So within, they've done a function get number. They give it the address, and they've set these modifiers here as public view returns uint. Okay. So let's see what it's asking us to do here. Quite a lot of stuff. Put it to the test. Okay. So we're going to define an interface called kitty interface. Remember, this looks like we're creating a new contract. We use the contract keyword. Okay. So let's try this. Contract kitty interface, and we are going to how do we do this? So contract kitty interface, and then so we need a function in here called get kitty. So function get kitty, and what is it going to take? So inside the interface, define the function get kitty, which should be a copy and paste of the function above, but with a semicolon after the return statement, instead of everything inside the curly braces. Okay. Everything after the return statement. Okay. That's correct. Okay. Inside the interface, define a function get kitty, which we've done. Okay. Oh, so similar to how we did before here, we don't need, I don't think. Oh, what's in the curly braces here? So this. Okay, so I think we could just paste this here. Okay, so this is similar to this. So we've got a function called get kitty, so get number. It's going to take a uint 256 called ID. The modifiers are external, view, and returns. But instead of just returning a uint, we're returning a lot of stuff here. So we've got bools, uint 256, with all these different values. So we've got boolean, which is just like a yes, no. So is it ready? Yes or no. Okay, and these are integers, so what is the birth time? It's an actual number, so it's a uint 256. This is just another data type, but don't worry, it's essentially just a number, an integer, which is bigger than 0. Okay, don't forget the semicolon, and let's give it a check. Perfect. Okay, chapter 11, using interface. Continue our previous examples with number interface. Once we've defined the interface as this. Okay, so we're going to put the interface to the test now. So how did they use this interface? So this is what we did last lesson. We created an interface. So to use this number interface within the contract, so they set the address And so to use this interface, it number interface. Then what is this name referring to? So now number contract is, so this is just like the name of the interface. Is pointing to the other contract. And we've said that the number interface, we've given it an address here, which is whatever address of the person or whatever address we defined. So that's how we create the interface. And now we can call get number from the contract, so we can use this and say this dot get number and give it, let's say, the message sender, the global address of the person who initiated the call, to some function. So with that being said, let's give this a try. So they've given us an address here, just some address. So what we are going to do is we are going to do, so like here how they did number interface, ours is called kitty interface. So kitty interface, and then we are going to call it kitty contract. And we're going to say it's equal to, so it equals the kitty interface when we give it this CK contract kitty maybe address. Okay, so similar to above, that's how we call it. Let's check our answer. Perfect. Okay, chapter 12, how handling multiple return values. So this getKitty function is the first example. We've seen multiple return values. Okay, so normally how we just return. Here you can see how here it's returning multiple things. Okay, this now instead of returning one thing, we're returning 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things. Okay, so how do we handle these multiple returns? So let's make a function called feed on kitty. It's going to take two parameters. One's going to be a uint called zombie ID. The other is another uint, and it's going to be called kitty ID. I'm going to open parentheses. The function should first declare a uint called kitty DNA. So we've got kitty contract dot get kitty. So this is from above here. So this is where we got the kitty contract. This is now the kitty contract needs to take an ID. So we give it, this get kitty function, sorry, so get kitty contract dot get kitty. So to run that function, we need to get the kitty ID from here, which is our kitty ID. Okay, but then now, so running this function returns many things. It returns all these things here. Okay, so we could have variables, and we could have let's see how I've done here. So we could have, say, we could have A, B, C, and what would happen is the first three returns would be equal to, the first one would be equal to A, the second one B, the third one C. But also what we can do is we can just use commas here. If we're not bothered about some of the return values, we don't want to store what they are, we can just use commas. So because we want here, what's it asking for? But remember that it returns a ton of variables, tend to be exact, but we only care about the last one, which is genes. Okay, so what that means is we need to do 9 commas, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we want to save genes. What it returns, the value for genes, we want to save in a variable called genes. Okay, and then finally the function should call feed and multiply and pass it both zombie ID and kitty DNA and check the answer. Oh, what have we done wrong? Let's have a look and see how they did it in some of the previous ones. So get kitty. This seems right. We give it the zombie ID, show from there, kitty DNA. Oh, what if we set the kitty DNA to? Where do we set that? The function should first declare a uint called kitty DNA. Oh, apologies, right. This is not genes. This should be kitty DNA, I believe. Yeah, stores genes in kitty DNA. Try again. What have we got wrong this time? 1, 2, 3, 4, 5, 6, 7, 8, 9. Does that not look correct? Let's have a look at the answer. So function feed on kitty. Oh, right, we've missed the public part. Okay, not the end of the world. So we just needed this modifier is public. Try again. Perfect. So chapter 13, bonus, kitty genes. So our functional logic is now complete. Let's make it so zombies made from kitties can have a unique feature that shows they're a cat zombie. Okay. So let's say our cat zombies have 99 as the last two digits. So our code, if we say if a zombie comes from cat, we set the DNA, the last two digits, to be 99 to make them a cat zombie, because these numbers affect our DNA values, which changes those traits of our zombie. So this is an if statement here. So if statements are used for like logic. So if this is true, whatever's in these brackets, if this is true, then do this part here. So if it's true, eat. Okay, don't worry about what this is too much. So let's say, so put it to the test. So first, let's change the function between feed and multiply, so it takes a third argument, a string called species. So where is feed and multiply? So feed and multiply is here. So it's going to take a third. It's going to take a string. Make sure we don't forget the memory part. And we are going to, and it's going to be called species. And then next, after we calculate the zombie's DNA, let's add an if statement. Let's tell us to add the if statement here. So if this Keka 256, if the Keka 256 hashes of the hash of species, I'm not sure if we need the Abby and code part here, and the string kitty. So if it's equal to, there's this, the string of kitty. Oh, it's equal string of kitty like this. I'll open up these parentheses. So if that is true, we didn't directly pass the strings. We'll pass. Oh, okay, so we do need this Abby code part. Someone feel free to enlighten me where the Abby encode pact originates from in the comments below. And so if this is true, so if this Keka 256 Abby.encode species, so if our species, where does this even come from? Oh, so this is coming into our function. So if that's equal to the string value of kitty, then we're going to do something. Okay, so what we're going to do if that's true. Inside the if statement, we want to replace the two last digits. So one way we can do this is we can do new DNA equals new DNA, which we defined here. And we can say is equal to the new DNA modulus 100 plus 99. Don't worry about this operation logic too much, but this is just to replace these last digits of the DNA so that we know it's a cat zombie. Okay, and then lastly, we need to change the function call inside feed on kitty because we changed the feed on multiply function to take three things. So this is it. So if we run the feed on kitty function, we're going to give it this. Oh, so we've got to see what it is. So it's going to be a string. It's going to store memory. So it's going to be called kitty. Okay, and then what we're going to use is we can use that kitty in our feed and multiply function. Oh, sorry. So I don't need to do this here. My bad. So in our feed and multiply function, we can now give kitty like this. And so when we run our feed and multiply, it's got this kitty value, and it's going to check if kitty is equal to this. That's correct. So, right, let's see what we've done wrong. Okay. So we need this kecker 256 rb.encode packed kitty. We need a few of these. Why have we got so many brackets here? Okay, so we need one to match here. Where do all these brackets go? So this one closes this. Oh, so this one closes this. Sorry, this one closes this, and that one closes that one. Let's try again. Okay, let's move on. So I didn't explain that one too well, but it's okay. So wrapping it up. So thanks for being with us for lesson 2. Let's do the final part. So let's give it a try. So now this is just a JavaScript implementation, which, what does it do? Once we're ready to deploy our contract in Ethereum, we just compile and deploy this zombie feeding. Since our final contract inherits from zombie factory. So this is the front end of how this would work. And so if we were to click, so this is the code for this clicking operation, I believe. So on this website, if we click here, then it's going to eat this crypto key and it's going to mutate our zombie like we've coded for. So yeah, perfect. That was lesson number 2 of the crypto zombie Solidity. Please leave feedback and comments below. If there's anything else you would like to, if there's any tips or new things we could learn, if you're an advanced Solidity developer and you want to give us some pointers or things we've missed, feel free to let us know. If you're a beginner and you're following along and you like it, what we're doing, let us know as well. So yeah, thank you very much, and hopefully I'll see you in lesson number 3. Thank you.